Hi guys, if you have questions, email me or write a comment.
Let's talk about the trigonometric ratios, the other part of trigonometry and the part that we are going to deal with all the time. And before we do that, we have to remember that if I'm talking about a right triangle, we have learned an important theory that is used most commonly in our life. We have the hypotenuse, which is the side opposite to the 90 degree, and we have the two legs, two sides of the right angle. The Pythagorean theorem says, Pythagorean, the Pythagorean theorem states that the hypotenuse squared is equal to leg 1 squared plus leg 2 squared. I bet that all of you know that. Let's just write this in a better way. Leg 2 squared. And most of you maybe know it by using ABC. You can call this side A, this side B, and the hypotenuse commonly is called C. So you can say C squared is equal to A squared plus B squared. It does make a difference as long as you know that you are applying the Pythagorean theorem and you know where are the letters that you are naming or using here. So let's keep this in mind when we talk about trigonometry. Now, where does these, or from where do we get these ratios actually? Why are we talking about ratios in trigonometry? Let's take this triangle for example. If I'm talking about, of course, I'm talking about right triangle. Let's say I want to talk about a 30-degree angle, or for example, 30-degree angle. Let's say that this angle was 30 degrees. From geometry, if you remember, or if you don't, the angle, the side opposite to 30, this side, which is opposite to 30, will always measure, or the length of the side will always be half the hypotenuse, will always be half the hypotenuse. So let's say that the hypotenuse is 4, then this side will always be 2. And if you try to apply the Pythagorean theorem, you will get that this side, which is the adjacent side to 30, will always be 2 radical 3. And if you try to do that in a different triangle with the same angle, let's say we have a different triangle, maybe we can make it a little bit bigger, stick it down here, make it obvious. If you are still talking about 30 degree, 30 degree in a different size triangle, let's say 10 as a side, and this is right, then the side opposite to 30 will always be half the hypotenuse, which is 5, and this side here will always be 5 by Pythagorean theorem, 5 radical 3. Actually, this is true for all the angles, not only for 30. The ratio between the sides will always be the same. So if you look at this here, let's say opposite of 30 over the hypotenuse, this will always give you 5 over 10, which is half. What about this one? This one will also give you opposite over hypotenuse. This will always give you 2 out of 4, which is still half. So actually, the ratio between the opposite side and the hypotenuse side of 30 will always be half. That will be true all the time. Also, the ratio between the adjacent side to the hypotenuse will always be constant, and that will be radical 3 over 2 for 30 here. It will be radical 3 over 2 if you try to simplify it. From here, we got the trigonometric ratios. So the trigonometric ratios talks about the ratio between the opposite side of an angle. Let's draw a triangle first. Let's say that we have a triangle here. And let's talk about an angle in general, not 30, in a right triangle. So we will have the opposite side of this angle, the adjacent side of the angle, and of course the hypotenuse, which is opposite to 30. The ratios between the opposite to the hypotenuse will always be the same for the same angle. 30, 60, 50, 10 degrees, whatever. And the ratio between also the hypotenuse over the opposite, of course, will be the same since it's just a reciprocal. The ratio between the adjacent over the hypotenuse will be the same, and the reciprocal of it, which is the hypotenuse over the adjacent, and of course the ratio between the opposite and the adjacent will be the same, and also its reciprocal, the adjacent over the opposite, will always be the same. So these ratios will always be the same as long as you are talking about the same angle theta. Here, instead of keep talking about opposite and adjacent each time, so we try to give them names. So in this case, when we are talking about opposite over hypotenuse, that would be called sine theta. And in case of adjacent over hypotenuse, this will be called cosine theta, which is an angle in general. And the opposite over adjacent will be called tan theta, or the tangent. Now, this is the reciprocal, so it's actually 1 over sine theta. This will be 1 over cosine theta. And this will be 1 over tangent, or tan theta. So I'm talking about the angles and their reciprocals. So the main three trigonometric ratios are sine, cosine, and tan, and their reciprocals will have their own names. So this one will be called, the 1 over sine will be called cosecant theta. This one will be called secant theta. Let's write them on the other side. This will be called, as I said, cosecant theta. This will be called secant theta, and this will be called cotan theta. So what do we have? We have the ratios between the sides. The ratios between the sides, opposite over hypotenuse will be called sine, adjacent over hypotenuse will be called cosine, opposite over adjacent will be called tan. Some people may use shortcuts to remember these. S for sine, O for opposite, and H for hypotenuse, they will say so. For cosine, C, A, H, so K. For tan, T, O, A, TOA. So Ka, TOA. You can use that to remember. So sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tan, opposite, adjacent. So Ka, TOA. This is an easy way to remember them. Now, how would I remember the reciprocals? That's also simple. If you look at here, the sine starts with S, the reciprocal comes with C. The cosine starts with C, its reciprocal secant starts with S, and tan and cotan are easy to remember. Tan, cotan. So sine with S, cosecant, cosine with C is the reciprocal with secant, which comes with S. Now let's have an example and try to apply all of these things on it. Let's say that in this right triangle we have an angle theta, and we have, let's say, this side which is 3, this side is 4. This is a famous triangle, and I need to find the 6 trigonometric ratios for this angle theta. How am I gonna do this? Before we apply it, we need to find the hypotenuse. The hypotenuse is missing. So if you're gonna use Pythagorean theorem, let's call it C. So by Pythagorean theorem, we should find C. So C squared equals A squared plus b squared. So c squared equals 3 squared plus 4 squared, which means c squared will be equal to 9 plus 16. So c equals positive 5 only. Of course, when you take square root here, you're going to use positive 5 only because side length can never be negative. So it's 5. So this side is 5. Now, what is sine theta? What's sine theta? As we said, it's opposite, so over hypotenuse, which means in this case, it's 3 over 5. Cosine theta is adjacent over hypotenuse, which will be equal to 4 over 5. Tan theta is opposite over adjacent, which is 3 over 4. What about the reciprocals? I need to find secant theta. As I said, secant start with s, so it's a reciprocal of what comes with c. So it's a reciprocal of, I'm going to do this in a different color. So it comes with c here. Cosine, secant. So it's the reciprocal of cosine, which is 5 over 4 immediately. The cosecant, it starts with c, so it's a reciprocal with what starts with s. So it's a reciprocal of sine, so it will be 5 over 3. Tangent and cotangent. So cotangent theta is a reciprocal of tangent theta, so it's 4 over 3, and so on. This is how you find trigonometric ratios, and this is from where did we get the trigonometric ratios. How did this topic start? It's a ratio between the sides for any angle. I hope that you understand now what's the meaning of trigonometric ratios and you know the basics of trigonometry.
Remember to like, share, and subscribe, and write your questions via email or comments.